Hey, 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 hey. So, guys, we are back online, and currently I will be working on learning uh, I will be learning the image segmentation magic. I can share here my Corsair screen because probably it's under the copyrights. But yeah, so currently I will be learning how to apply different or multiple masks to the image. Um, so I will listen the video from Coursera on another monitor, on another display, and I will be sharing with you what I got during this video, what I got from this video.
Sometimes you may not have a single mask that produces the segmentation you want. For example, segmenting all of the colored chips from this image. However, a combination of the masks will produce the desired segmentation. In this video, you'll learn to handle situations like this by combining masks using AND, or, as well as not logical operators. To start, let's take a look at how we got to this situation in the example you just saw. Since the chips are circles, a good first approach to segmenting them is to open the Image Segmenter app and use Find Circles. Adjusting the size and sensitivity segments all the yellow chips, but not the other colors. This is due to the foreground polarity being set to bright. Changing the foreground polarity to dark segments all of the remaining colored chips. So, generate a segmentation function for each polarity setting to create the masks in the script. Then, open a script and load the image. Next, use the functions generated from to create the masks in the script. Then, open a script and load the image.
Okay, so here we go. We need to load initially image. Okay, this one. Let's see what is it. Okay, here it is, and we need to find circles, etc.
Next, use the functions generated from the app to create the binary mask for both foreground polarities. Remember, to combine binary masks, use AND.
Okay, so here is image segmenter up. Image segmenter map. Oh, sorry, here it is, right? Where it is? Okay. Image segmenter. 1 second. Mm, Okay. Image segmenter mask. Sorry, image segmenter tool. Sorry, I'm stupid. Image segmenter. Okay, it's loading this image segmenter. Okay, and now we need to find circles, and basically based on choosing the different foreground polarity, we can find the different circles with different background, right? Uh, 1 second. What's up?
Binary map. So, generate changing the foreground polarity to dark segments all of the remaining colored chip.
Okay, as you can see, we found some circles. Okay, we found more, and generate function. So yeah, basically what we did, we basically can change it to be like this one.
Then ground polarities.
Okay, segment chips bright. This is our function, right? And now okay, do we have this function? Or probably hey, I need 1 second. So here is the function, right? Okay, this is like command window, and this is like a script, right? Okay, probably this one is correct. how, okay, run section. Okay, and for example, if we change here to dark, then what would be, how would it work? What's up? Ah, okay, I know. That's because we need to load again RGB, right? And then let's add like two separated functions just uh, to see what is the result. RGB, probably we don't need it, right? We can do it like this, and then we can do the montage magic. And okay, and we need, so this one is for bright, right? Okay, okay, and now let's try it out. Why? What's up? Ah, because we need to load RGB, right? Because RGB is already changed, I think. Okay, that's interesting. Okay, so as you can see, so we highlighted different circles of the different color. Okay,
Remember, to combine binary masks, use AND, OR, and NOT logical operators. In this case, we need the OR operator to get the portions of the image where either mask is true. Now let's check the result. This looks like it should segment all the chips. Let's take a look at the result of applying the mask to the image.
yeah, so basically they also propose to use this operator or this is operator when we like compare two sets of values to two sets of numbers, and whatever is true being considered as it's also the true in the resulted image. So for example, if it's dark pixel 0, then it would be the same in both in the resulted image. So let's just compare how it looks. Okay, as you can see, now we have got like all circles in one image.
First, create a copy of the image. Then, apply the mask. Use the repmat function to duplicate the binary map.
By the way, I suggest to read OR operator, Wikipedia, software development. So you can learn a bit about OR operator. Binary OR operator, probably. I'm just curious because yeah, OR. So for example, if we have such a binary number, then at the end, in the resulted number, we should have in each bit 1 if it's either 1 in one of the like attribute like values that we applied to this OR operator. So yeah, this is just for you to get a bit more knowledge.
Into all three color planes.
Okay, and now we can probably put back the color into the image, right? So basically we need to what this function does. Okay, so it okay. So a bit of refactoring here because we need to use this variable later, right? Okay. And now we just need to okay. I understand what we are doing. Okay, montage. I don't need this one. I missed. I don't like this. So a RGB masked image, but I don't need. Where is it? RGB. That's okay, right? Masked image. That's okay. RGB bright, RGB dark. So I don't like how it behaves because it should work a bit different way, right? I mean, we should have something like this one. We should have something like this one. And why it doesn't work this way? And why it doesn't work this way? That's strange. I'm not sure. So okay, so this is interesting. Okay, okay. So I understand, but not exactly. Uh, how do I stop or because I believe this is like okay section break, but it doesn't make sense. Why? So we load the image. That's okay, right? Okay. Let's okay. So here is okay. But what's going on with this thing? Really? But it doesn't make sense. What's wrong? So that's okay. Let's check masked image. What is it?
Looks good. Use the repmat function to the image.
That's interesting.
In your applications,
So basically, I made exactly what was told or what I saw in the video, but it doesn't work. Why? Hmm. Why it doesn't work? Why it doesn't work? Why? What happens if I do it like this? Masked image, RGB. But we didn't change RGB, I think, right? Let's like read again from the file system, because it's strange. Why? Really? That's interesting. Okay. Okay, so as you can see, the problem is that we are not able to show it like together, but it should be released, I think. Oh no, still doesn't work. I did it million times. What's wrong? No, this one doesn't work because it's incorrect syntax, right? So then, what is the problem? So we tried to show two images at the same time, and for instance, if we show now RGB, how does it look? That's okay. The only problem is that we can't show That's interesting. Why? Why? Hmm. That's stupid. We are like trying to show what? How do I debug it? I mean, I won't understand. So we are showing it like it's like in progress, or what do we show here? What is it? What is this? Okay, probably I need to investigate it maybe later, because it's not clear. I mean, we have got correct image as we had to. Here it is. But why this montage doesn't work? That's strange. I don't know. So
You may need to combine more than two masks to make more complex relationships, but you can always break the combinations down into single operator pairs.
yeah, also they suggest that we can like use different binary bitwise operations, and or XOR. So it's like basic Boolean operators, I would say, right? And now I will be listening to how to use clustering to segment images.
Segmentation is not always binary. Some applications require labeling multiple objects in the same image. For example, in this image, what if you wanted to segment each chip color separately? One possibility would be to create a binary mask for each color using the Color Thresholder app. Then, combine them into a multi-label mask. However, this could be a bit tedious. A method that will directly result in a multi-label mask is clustering the image into regions with similar properties, in this case, color coordinates. Clustering is a mathematical technique for grouping data such that the elements of each cluster have more similarity with each other than elements of other clusters. You can see how the distinct colors in this image form clusters in different color spaces using the Color Thresholder app. Like with color thresholding, it's often advantageous to use an alternative color space when clustering. In this case, the HSV space appears to have the best separation of the chip color coordinates. To convert your image into this color space, use the RGB to HSV function. Next, clustering algorithm will need to know how many color clusters to label in the image. There are 5 colors of chips, 1 black pen, and 1 wood-colored table. So, let's start with 7 labels. The imseg k-means function will perform k-means clustering on the image. Note that it requires the input image to be of data type single. The output is a matrix of pixel labels. Each element in the matrix is a number specifying the cluster the corresponding pixel was assigned to. To compare the label matrix to the original image, use the label2RGB function.
That's interesting. So basically, we would use here k-means algorithm, and let's basically. So this algorithm is used heavily in machine learning and clustering mechanisms. So we want to split up image into 7 clusters, and we need to segment image, right? So we don't have HSV because this is the transform to HSV space image, right? Okay. K, what's up? But we do have K, right? Okay. This is, it should be the uppercase variable, right? So and now we can see the resulted image.
Viewing the label matrix shows that the table pixels
Something wrong, I mean, something wrong with this montage function in my case, because I see absolutely different thing. So let's see separately this image. Yeah, so it looks, as you can see, I'm not sure if, but yeah, a lot of noise, but looks pretty interesting.
Fell into 3 clusters, and not every color of chip got a unique label. K-means clustering divides the color data into K clusters, using the distance between points as a measure of similarity. In this case, you can see many pixels for the table spread over a range of brightness. This volume is being broken up into multiple clusters. However, notice that the pixels belonging to the pen and table are all lower saturation than those belonging to the colored chips. So, let's use this to segment the table and pen out of the image, and then try clustering the colored chips on a black background. It looks like a saturation threshold of about 0.75 works well to separate the table and pen from the colored chips. So let's add that to our script. The saturation values are in the second coordinate plane of the HSV image. So let's assign a binary mask true where these values are greater than 0.75. Next, create a copy of the image. And then
So the problem is that we need to improve saturation here. Okay.
apply the mask to zero out the table and pen. Remember, you need to apply the mask to all 3 color coordinate planes with the repmat function for color images. Finally, to visually check the results, IMShow needs the RGB version of the new image. Looks like it worked correctly. Now, let's copy the clustering code. Update it to use the image we just created, and change the number of labels to 6 to capture the 5 chip colors and black background. It looks like each chip color.
Okay, and now we need to apply the same clustering algorithm to this function, to this image, with removed wood background. So, and now we need to show the result of it. Okay, it looks similar to what I have in Coursera. Maybe not 100%, but looks similar. So basically the idea is that
now has a unique label. In general, clustering can be an efficient way to segment an image into several distinct color regions. You may find that using a particular color space will help the clustering algorithm, and, as in this example, you may need to combine clustering with other segmentation approaches.
okay. So basically yeah, we know how to use k-means, This is like one of the root algorithms in the machine learning. So so now we need to pass some kind of exam. Okay, that's some kind of test. Mm, so I need to okay. Hmm. But okay. Advanced segmentation approaches. Calculating region properties. Okay. 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 Where is this puzzle? So this is a module 1 or okay, but then it should be here, no? Where is this image? No, not here, but that's interesting. Maybe, but no, it should be here because it's like files from the course, right? Okay, okay. So yeah, this one, and that's okay. So let's see this image. Okay, interesting. By the way, I can't show the because that's like graded assignment in the Coursera, so it could be violation of the content, private of copyright for the content. So I will do it like in the background. So basically, we need we need so we need to find like or segment image into different areas, right? Okay. Oh, that's a mistake because I wanted this one. I don't know why I choose this one. Okay, if I go to this one, okay. Okay, so now I can share it back because I completed the task. Uh, so I think uh, I'm like done. I mean, I need to complete one. I need to complete graded application in Coursera. Let's see. Answer this. Okay. Okay. So I need to complete. So here is the thing that I wanted to talk about. Um, Basically, the most important thing for me is to make sure that I know how to I know my diagnosis, but at the same time I need to get rid of this diagnosis because currently I'm addicted to all these computer things, and for example, I can't work without watching. Uh, I can't work without watching TV and other things. Uh, but yeah, I think this is the goal because, for example, today I spent like 30 minutes on computer without watching any kind of trash. I was learning, I was doing some good things, right? So now I will take small break, maybe few minutes, I don't know, just to grab the cup of tea, and then I will be back to stream how I am developing, but it will be from Linux because currently I forced to use Windows for MATLAB because that's what I'm learning right now on Coursera. But yeah, the next thing that I wanted to talk about or share is I will be learning some math probably and development thing. You know, I'm not a huge fan of vibe coding and all these AI things because it might be okay but if you need to learn something, then you need to learn something and uh, touch it, right? To understand better what is the inside of these tools, etc. So I need to learn a lot of things this year because my family depends on it, and to be honest, this is about getting or enjoy the things, right? And by the way, today also we are gonna watch another episode from Jeff Nippert about some fundamentals um in our regarding fitness, regarding sport industry. So let's stay in touch